All right, guys, not going to be very long. Okay, I only have 6 more structures. Before we do, let's quickly review over the structures that we already have. All right, if it's a double bond, what do we call it if it's a double bond? Jordan, double bond is an double bond. Alkene, very good. If it has hydroxide, Hannah? Alcohol. If it has a double bonded oxygen on an end, a double bonded oxygen on an end. Can you find your notes there, Lillian?
It's somewhere in here.
I hope so.
Here it is.
Double bond oxygen on an end.
Aldehyde.
And what do we call a double bonded oxygen? It's got a special name. What's a special name there? Jordan? Double bonded oxygen is called carboxyl. Very good. If it has a double bond oxygen anywhere except on an end. Hannah? A ketone, very good. If it's got a triple bond, Lillian?
Alkynes.
Alkynes. If it's got a single bond, George?
Alkanes.
Alkanes. I think that's all of them, isn't it?
Yeah.
Are we over? All right, so we had 6 last Friday. We're going to do 6 today. Tomorrow, you're going to have 30 problems to go through and identify and a practice. And the test on Wednesday will be 40. Does that sound too terrible? All it's going to be is the structure there and you name them. And you're going to have to know them. I promise they will not be open there. Okay, so you're going to have to know them. Okay, because otherwise that would be way, way, way too simple. All right, so first we're looking at carboxylic acids. Carboxylic acid is an organic structure containing a carboxyl. Again, that means a, what's that carboxyl? Double bond oxygen on the first carbon with a hydroxide, there as well. So a carboxyl and a hydroxide on the first carbon. Okay, so the generic form then looks like that. R just means some chain. That could be 1, it could be 1,000,000. Doesn't matter. The way that we name it, okay? So if I have just 1 carbon, 1 again is meth. So that would be methanoic acid. Oic acid is our acid, carboxylic acid. Get a little more complicated there. A little bit more complicated. C, double bond O, OH, CH2, CH with a CH2, CH3, C with a CH3, CH3, CH with a CH2, 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 CH3, 4 CH2s and a CH3. Now we put them in alphabetical order. So that's an F. Those are meth. That would be a but. So that when we go first alphabetically, so we would name it 5-butyl, 3-ethyl, 4,4-dimethyl, and there's 10 carbons across it. So we exactly know what that's. Now, if we'd had more time, you would have been naming it, but unfortunately, we just plain ran out of time. So I wanted to get you a chance to look at that and make sure that we were taking it down. Okay, good. All righty, next structure are called ethers. Okay, now what are ethers usually associated? Does anybody know what we used to use ethers for? When we used to do surgery, we used to put a towel over the patient's face and pour an ether on top. The main reason is that it's an oxygen between 2 carbon chains. So it's bonded as a double bond as an oxygen wishbone. the body can see that like oxygen and would take it in the same way as oxygen. But since it's not oxygen, when it ends up going to the brain, it would deprive of oxygen and would knock you out. Now, they no longer use that as a primary purpose because occasionally, if you weren't a very good doctor, you gave the patient too much ether, they wouldn't die, but they also would never wake up again because it would basically cause brain damage. Okay? Now, the structure itself is an oxygen between two carbon chains. Okay? Oxygen between two carbon chains. We name it as if each end was an additional group. We name it as each end was an additional group. Okay, good. All right. Now, so this one would be one carbon and two carbons. One is one again. Do you guys remember which prefix for one? Meth. Two is my English professor Burks. What starts with an E? F. So it's ethyl methyl ether. Ethyl methyl ether. Okay. Groups are arranged alphabetically. Even though it's shown the other way, the molecule can't flip around, it doesn't matter. We put ethyl before methyl. Okay? All right? And go on, try and name that one. That would be pretty simple. What is one carbon? But they're the same, so you use a prefix. Which prefix are two? Dimethyl. Dimethyl. Yeah, we could call methyl methyl ether, or chemists are lazy, that would be dimethyl. Now, I really wish we had had more time because we would have made a lab where you would have taken methyl ethanoate, otherwise known as wintergreen, and you would have made that wintergreen smell in the lab. But we just plain ran out of time. So, okay, what is an ester? Compound forms a reaction of carboxylic acid with an alcohol. Compound from the reaction. Basically, it's actually a form of a polymerization. Okay, it's a hydrolysis. We're going to form water, take water out of the process. Okay, so there's our alcohol. Remember, it has the OH. There's our carboxylic acid. We're going to generate water, and then we're going to get our ester. So an ester is a chain, oxygen, carboxyl, and a chain. Process is called esterification. We treat the end resembling the ether as if it were one, and we take the ik off the acid and replace it with A. You guys any fun this weekend?
Yeah.
Oh, that'd be nice. On French Creek?
Well, Oil Creek.
Oh, okay. Cool. Asthma kicked in, I didn't do much. I had a baccalaureate service for 7. I'm sitting there playing the entire time. So it happened. My son's baccalaureate service. Lungs. You know. All righty. So if we were to name that one, that would be like a methyl, and 2 is ethyl, ethanoic acid. So we name that as methyl ethanoic. Methyl ethanoic. Otherwise, known as vinegar. I'm not going to have you name these on a test. You just have to identify the type. That's all. So Vanessa, all we're looking for is the oxygen carboxyl inside the structure. Oxygen carboxyl inside the substructure. So if I was this one, it would be pentyl, 2 methyl heptanol. 5, it's your pentyl. On the second carbon, we have a methyl. 1, 2, 3, 4, 5, 6, 7. Hept. Good. Fourth structure, amines. Amines. Amines, organic structure with an NH2 and amine group on it. Okay, with the NH2 and amine group. So carbon chain, CH, NH2. Amines a carbon chain. We name it by typing the carbon chain as an additional group and stick amine on the end. We name it by treating the carbon chain as an additional group and stick amine on the end. So, one carbon, what's one again? Right? So that would be methylamine. I've got 3, 4, 5, 6, 7, 8. But on the 1, 2, 3, fourth one, I have a propyl. So this is 4 propyl octyl amine. Like in 2 banana shape of onion, because you're not going to need it. This so you have it as a reference. All good. All right, so that is 4. 2 more to go. Amines. Amines. An amine's like an amine. The difference in amine is that a carboxyl is on carbon 1. Okay, so amide is like an amine. The difference is there's a carboxyl on carbon 1. So we have our NH2, our carboxyl, and then the carbon chain. We name it like an alkane, but we replace the E with amide. Good. All right. So I have 2 carbons, right? 2 is my English professor burps. 2 is F, right? So this would be ethanamide. Ethane, take the E off and replace it with amide. Ethanamide. Okay. All right. Got 1, 2, 3, 4, 5. So that would be pent, but we have on carbon 2 a methyl, carbon 4 a methyl, and carbon 3 an ethyl. So that would be, make it a little bit larger there. Oops. Stretch it out. 3 ethyl, 2,4-dimethyl pentanamide.
The following students please report to the production lab with their iPads. Caitlin Fry, Derek Villajunas, Hannah Hargenrader, Tegan Hargenrader, Landon Phillips, Jordan Downer, Josh Guilford, Ethan Peterson, Mackenzie Williams, Kevin Lewis, Richard Webster, Zach McGowan, Kevin Lewis. Thank you.
All right. Last structure. These are actually, I think, one of the most fun. The aromatic hydrocarbons. We have an aromatic hydrocarbon. It's a benzene ring, which is C6H6. Okay. Now, benzene really messed people up because they couldn't quite figure out the structure. So a scientist had a dream of 6 snakes. 1, 2, 3, 4, 5, 6. And 3 of them were poisonous. So they bloated up when they got bitten. So we have a double bond. We have resonance structure here. Chemists don't want to have to constantly write resonance. So what we do instead is we put a hexagon with a circle inside a little bit, and that represents a benzene ring. Whenever you see a hexagon with a circle, that means there's double bonds resonating back and forth. We just don't want to have to do that every time. Does that make sense? Yes? Good? All right. Now, there's a lot of different names here, okay? So we're going to go through them, draw them. You're not going to have to name them, but they're just good to know, okay? If I put a CH2, CH3 on the end, that's an additional group. So we name it like an additional group. So that would be ethylamine, ethyl benzene. Right? I had to start with 2 because there's one structure with only 1. If I put a hydroxide there, that's called a phenol. Now, phenols, if you look at medications, a lot of phenols are used in medications, which is strange because benzene is carcinogenic. But you put a hydroxide on it, the body can process it in and out to the liver, and we're good to go. All right? So if it has hydroxide on it, it's called a phenol. Now, you see I start with the CH2, CH3 because with just the CH3, we have a special name for that. That's called toluene. If I have one with just a CH3, just 1 carbon, 1 methyl group in there, that's called toluene. Okay, a couple more structures here. If I put a, that one didn't want to stay there, just want to stay back. Oh, what the heck? Oh, back. All right, so if I have a aldehyde on it, we call that benzaldehyde. Benzaldehyde. And you would have to know how to name all of these fun things. Dang it, shoot. Let's see, you're so disappointed you have to do that. All right. If I put a carboxyl hydroxide on it, that's called benzenoic acid. If I put an amine on it, it's called benzanamide. Benzanamide. Sorry, benzamine. Oh, there's one more. The last structure there is nitrobenzene. Now, nitros are really interesting because the NO2, that's a double bond, single bond in there. There's a lot of energy with that. and then you put that with the benzene structure, there's even more energy. So a lot of stored energy whenever we're using a nitro group involved with that, okay? So we can put additional groups. When we do additional groups with aromatics, they're different. If I have them placed on 1 and 2, that's called an ortho position. 1 and 2 is an ortho, so we call that orthonitrobenzene. Ortho tells me if there's 2 nitros on the 1 and 2, right? If it's 1 and 3, that's metabenzene, meta-nitrobenzene. And 1 and 4 across each other is called a para position. Para-nitrobenzene. So if you have right next to each other, that's ortho position. 1 and 3, that's meta. 1 and 4, para. Okay. I have one last structure. I just think this structure is really cool. Write it down, and let's see if we can try to name it. Okay. Okay, I have 3 NO2s. What's the prefix for 3? 3, prefix for 3. Mono, di, tri, right? So, tri. Okay, and what is NO2 called again? Nitro. And then what is a benzene with a CH3 on top again called? Toluene. Okay, toluene. Now I didn't have to capitalize the N or the T. In reality, it doesn't have to capitalize the N or T. The reason I did, hopefully this works right. Didn't give enough time. T. Oh, sorry, that one did get enough time. What's TNT known as? Dynamite! Yeah, whenever you have dynamite, that's trinitrotoluene. There's a lot of energy. In fact, it's so unstable that if you have dynamite, you let it sweat, it'll explode all by itself. It's basically nitroglycerin form. Does that make sense? Is that cool? All right, any other questions? With that, we're done. That's it. All righty. And with that, we're done at home. That's it. Hopefully it wasn't too bad. Hopefully you got these down.